Hello all. So we are in unit 4. In the last sessions we were talking about classification algorithm, the second supervised machine learning algorithm. While we have studied about regression in unit 3, we have started working on classification in unit 4. So today in this session I would like to talk about one particular classification algorithm which is called as KNN. Okay, so we will discuss about what is this KNN algorithm, what are the advantages, disadvantages, and how do we implement KNN algorithm in detail. Okay, so when I talk about KNN, NN stands for nearest neighbors. Okay, so K nearest neighbor is one of the popular supervised machine learning algorithms which we use for both classification and regression, but mostly because of its nature of working we use it for classification. But remember, you can use KNN regression also and you have KNN classification also, but most probably we will be using it for classification. Okay, so KNN is a non-parametric algorithm. So when I talk about non-parametric, it means that we do not take any assumptions on the existing data or the underlying data. Okay, so there's another name for k-nearest neighbor algorithm which is also called as lazy learner algorithm, because it does not learn from the training set immediately, but instead it actually stores the data set at the time of classification and it performs actions on the data set and then give you the result. Instead of just learning from the data set, it stores, learns the actions from the data set and then give you the results. That is the reason it is also called as lazy learner algorithm. Okay, now as you can see we have an image of a creature. Okay, this is the input. We have an image of the creature which might look, which is looking like a cat and a dog. We are confused about which particular animal it is exactly. Okay, so in order to differentiate or classify whether it is cat or dog, we use KNN algorithm for identification. Okay, so we train the model. For training the model, we first store them, analyze that with respect to the given input and then produce the output. Okay, basically understand that KNN works on a similarity measure. Okay, that is, our KNN model will actually find the similar features of the new data whenever we give any new data. So it compares the similar features of the new data with the existing data that is available which we have taken for training, and then based on that similar features it will classify whether it is a cat or a dog. Okay, now why do we actually need a KNN algorithm? Okay, suppose we have two categories. Let's see here, I have category A and category B, where in category A I have green circles and category B I have orange circles. Okay, now we have this new data point coming. Okay, let's say this new data point is some blue dot. Okay, now I have to decide to which category does this blue data point belongs to. It is actually in the middle, right? So it is very difficult for us to classify whether it belongs to category A or category B. So with the help of KNN algorithm, we can easily classify to which category that particular new data point will belong to. Okay, now as you can see, before KNN the blue dot is still lying. We are supposed to decide whether it comes to category or B. After you apply KNN, we have decided that the blue dot belongs to category A. Now how did we decide that? Based on the nearest neighbors. How do we calculate that nearest neighbors and all? We will see now. Okay, now how does KNN actually work? Okay, the KNN actually works by these 6 steps. Now let's see one. First you have to select how many neighbors do you actually want to consider. When I take about this particular point, if suppose I say I want to consider 3 nearest neighbors. Okay, so when I take 3 nearest neighbors, this is one, this is one, this is one. Okay, now these are the 3 nearest neighbors, out of which 2 are lying in category A. Hence I have decided that the new data point belongs to category A. Okay, so first of all you have to choose how many number of neighbors that you have to consider, that you want to consider, and then directly not calculating that. See, considering the nearest neighbor is our assumption, how many numbers. Okay, but not just that, you also have to calculate the Euclidean distance between k number of neighbors. Okay, so you have to calculate the distance between this and this, distance between this and this, distance between this and this. Okay, when you keep k is equal to 3. Okay, after you calculate the Euclidean distance, take the k nearest neighbors as per the calculated Euclidean distance, and among these k nearest neighbors, count the number of data points in each category. As I told you, if suppose I take k is equal to 3, I will calculate the distance and the less distance one. Okay, so whichever the category has more number of nearest neighbors to that particular data point, we will categorize the new data point into that. Okay, so assign the new data points to the category for which the number of neighbors is maximum, and then finally our model will be ready. Let's see that with an example. Okay, so as you can see here, firstly we'll choose the number of neighbors. We will, let's say k is equal to 5. Okay, now in this case when I say k is equal to 5, you have to calculate the Euclidean distance between this and this, this and this, this and this, probably this and this and this and this. Okay, 5 nearest values. Okay, and then we'll calculate the Euclidean distance between the data points, and then like what we have studied, the neighbors which have the category which has more number of values less in Euclidean distance calculation, the new data points belongs to that. Okay, now how do we calculate Euclidean distance? If suppose I have a new data point a1 and b2, if I want to calculate between a1 and b2, I say x2 minus x1, x2 minus x1 whole square plus y2 minus y1 whole square. What is this a and b? The distance between the 2 points. What is this x1 y1? The x1 value, the x-axis value and the y-axis value. So Euclidean distance is calculated as square root of x1 minus x2 minus x1 whole square plus y2 minus y1 whole square. Okay, so by calculating this Euclidean distance, we will get the nearest neighbors. Okay, now as you can see, if suppose I take k is equal to 5 in this example, as I told you, let's take k is equal to 5. Okay, now when I take k is equal to 5, I have 1, 2, 3, 4 and 5. Now I calculate Euclidean distance between this red point and all these 3 green points, and red point and these 2 blue points. Now after I calculate the Euclidean distance, I found that the nearest neighbors, after calculating the Euclidean distance, the nearest neighbors of green are more in number. Hence, I say this particular thing belongs to category A, because 3 data points in category A, 2 nearest points in category B. Hence, it belongs to category A. Okay. Now, the major challenge here is how do we select the value of K? I am randomly assuming k as 3 or k as 5, but how do I fix to this? This is the challenge in KNN. Okay, now there are some points which will help us selecting the value of k in the KNN algorithm. Basically, there is no particular way to determine the value of k, so we need to find the values to find the best out of them. Okay, just assume k is equal to 3, 4, 5. Okay, so basically we will put k is equal to 5, or a very low value of k is equal to 1 and 2. What will happen is it will make the model noisy, okay, or lead to the effects of outliers in the model. Hence, we don't take large values of k because it may find some difficulties, not too small values of k as well. So probably or preferably we will put k is equal to 5 in general. There's no particular rule in understanding about what value of k I actually choose. Okay, now let's see an example on how classification works with an example. As you can see, if you find a data sets, right? So I have only one class which has two values, red and blue. Okay, I have two classes, red and blue. Now I have two features, feature x and feature y, which has some values. Okay, now a, b, c, d are the data points. A, b, c, d are the data points. As you can see, a and b belongs to red, a and b belongs to red, c and d belongs to blue category. Okay, now I have a new data point here. What is the value of x? 1 comma 2. What is the value of b? Sorry, a is 1 comma 2, b is 2 comma 3, c is 3 comma 3, and then d is 6 comma 5. Now when I encounter a new data point, first of all you have to pick the value of k and then calculate the distance between this point and those k points. After that, the value with near k points would be considered. Okay, now let's see this. Okay, now I calculate Euclidean distance between a and the new data point. Okay, x1 minus x2, y1 minus y2 whole square plus x1 minus x2 whole square. Okay, now when I calculate this, we see that 2.83, 1.41, 1, 3.16 are the Euclidean distances. If suppose I take k, I can't take k is equal to 5 because I don't have that many data points. Okay, when I assume k is equal to 3, then 1, 1.41, 2.83 are the smallest values. So C has 1, B has 1.41, A has 2.83. So these three are the nearest neighbors. So C has blue color, B has red color, A has red color. So out of these three nearest points, A and B has red color, that is the maximum number, majority class is red. Hence the new data point will be considered as red. Okay. So this is how your KNN works. Okay. So when we talk about some advantages of KNN, we say KNN is simple and easy to understand. It does not make any assumptions about the distribution of the input data or the data set that is available, and works both for classification and regression. When I talk about disadvantages, it is computationally expensive because distance calculation for all the training point would be difficult when you have large data sets. Here I have taken only 4 data points A, B, C, D, but if you have 4 million data points or 4,000 data points, so calculating distance between each and every point would be tedious, okay, and then requires storing the training data set as I told you, and then can be affected by noise if you take too small value of k, and the selection of k, the value of k that we have to take actually significantly affects the performance, because we are not sure about what value of k should be taken. That is all about your assumption. Okay. So where do we use KNN algorithm? For handwritten digit classification, we have digits 0 to 9. Okay, so you different ways in which we can write the digits, and if you want to classify those handwritten digits, we will be using KNN. Okay, and then recommendation systems, when you want to recommend a product or something, we also use KNN. And then disease classification in healthcare. Okay, prediction of cancer, prediction of diabetes, so many predictions in healthcare will be using KNN. And then fraud detection in banking. Okay, so these are the applications where we use KNN. Okay, so this is all about the first classification algorithm, K nearest neighbors. Thank you.